And in order for you not to have to learn at the operating system level how to handle those events, you just have to do it to the runtime. And so as a programmer, it lets you focus on solving a business problem rather than solving the problem to listen for the mouse click.
Mm-hmm.
And that's called, I mean, if everybody had to go and write that same code, that's boilerplate code. Is everybody's going to do the same thing? You know, it's like you wouldn't do it any different than anybody else. So why not embed it into the operating system level and let the operating system notify your runtime? It's like, hey, by the way, you got a mouse click, you know, and your application is like, oh, yeah, I've been waiting for that mouse click here. Let me take that. And now I can run the logic, you know, or I've been waiting for this keystroke, or I've been waiting for the person to click on a button, you know, and now, you know, the operating system notifies your runtime, which, you know, runs whatever logic you've programmed in order to make things happen. So everything is kind of based on events.
Mm-hmm.
Does that make sense?
Yeah, yeah.
You with me so far?
Yeah, I am actually. I didn't realize like how connected computers and like the hardware and the like the program that you write are like so connected to each other.
Yeah, yeah. I mean, it's phenomenal to imagine how much the browser is doing.
Mm-hmm.
You're simply putting these little tags, these HTML tags, and you're applying some CSS, and then you're writing this JavaScript code. And, you know, for you, it doesn't matter if it's running on Safari. It doesn't matter if it's running on Chrome, Edge, Firefox, or any other browser that's out there. The browser happens to be your runtime.
Mm-hmm.
And the browser has its runtime, which notifies the operating system. It's like, hey, here's the graphics that we're displaying. Go ahead and put them on the screen. And here's the size of my window. Make sure that you're only staying within that sandbox of my window, you know?
Mm-hmm.
You know, if you maximize your window, you know, it notifies the operating system. It's like, here's your real estate to be able to draw what you need to draw based on these HTML tags, based on the CSS, and based on the JavaScript that's executing. So once you add the browser into there, the browser even has a
Mm-hmm.
you know, another 10, 15 layers of abstraction, you know, that need to be accounted for. So yeah, I mean, you're basically running on layers of abstraction versus abstraction. And, you know, you would think is like, man, this really could slow things down. But hardware is so fast these days that the time that it takes to execute some of these things is minuscule. I mean, if you were to try to program directly to a piece of hardware, the difference in performance would be like splitting hairs, you know, and it's like, that's how much of a performance improvement you would be gaining. It's like you would be splitting a hair, you know, and it's like for the amount of proprietary code that you would write in order to make something work that much faster, it's not even worth it. You know, you might as well just go through those layers, because then you can focus on much bigger things, you know, better things, you know, mm-hmm. to be able to do that. So let's work backwards, right? So we got the layers of abstraction, we got the runtime, and then you got your program. And so your program ends up going through a compilation process that then your runtime executes. Excuse me for a second. So your program gets compiled into either computer code that it can understand, or some kind of intermediate mm-hmm. Format that your runtime understands, and it's much more efficient to be able to work with that than to be able to work with your actual program itself and interpret what you're trying to run. What makes it a seamless line between your program and the binary are the tools that you're using. So let's look at things like Visual Studio or Visual Studio Code, right? If you create a website with using just HTML, what do you have to do? You just right click and say open in live server, and it opens up your browser, and next thing you know, your website's there, right? So it's the tooling that needs to do it. Otherwise, you need a web server, you need to deploy your code to the web server, and then you need to open up a port to that web server that's hosting your application, and then you open up your browser to connect to that port, and then comes up your website. But you've just skipped all these steps by simply right-clicking and saying open up with live server, and boom, there's your website. You know, it's like the tooling is what makes it seamless, you know, but there's so much more there. And as we start getting into deploying, like, say, a website, you know, hopefully we get to that point in this podcast, we're going to see that we do need to know about those particular layers. As you're learning, you really just need to focus on learning the language, learning how to put this technology together, and forget about everything else that's in between. Go ahead and take advantage of that right click and run on live server and just enjoy your website. Because once you start deploying it, that's when you start like, oh, I didn't realize that I needed to set up a web server that's going to host my website. Oh, what do you mean I got to open up a port on the firewall? And oh, wait, now I got to allow public traffic, but only through port 80. You know, there's all these things. And it's like, oh, Chrome doesn't allow you to run port 80. You got to run it on port 443, which is the secure socket layer port. And you're like, oh my gosh, okay. And I can't just host a website on 443. I actually got to put a certificate together that then can be honored by the browser. And, you know, there's all these steps, and you don't realize that until you actually have to deploy the application. But that's so far down the line, you know. Yeah, but
I didn't understand a lot of that, but it does make sense. I always wondered what like those ports mean when I'm like trying to hook on to like the website and stuff like that. Like, what does this mean?
Yeah, exactly. My point here is that as you're learning to program, don't worry about the details. It's like, how would this work when I deploy it? You know, it's like, we're going to get to that, and we'll worry about it when we need to cross that bridge. We'll cross that bridge when we get there, is what I'm saying. And so, but what's interesting about the tools, okay? If you look at a tool like Visual Studio is written in C++, or it could be written in C#, who knows? But what's funny is that you had to come up with C# in order to create a tool to build C#. It's kind of like the chicken and the egg thing, you know? Let's use an analogy. You can make hammers with hammers, but that first hammer still needs to be made, right? Yeah. That hammer needs to come out first before you can start using that hammer to make other hammers. Where does that one hammer come from?
It starts as a rock or something.
It starts somewhere, right? And I guess my point is that first hammer that you make may not be the exact hammer that you use to make all other hammers. It could be a hammer that's good enough to make that first hammer that's really going to be the one to make all the other hammers, you know, in order to really be able to forge that metal and make it strong, you know, because that's the whole thing about hammers, right? Is that you got to heat them up so that the internal portion of the hammer is soft, but the external portion is hard. And you do that through just, you know, pounding that metal and, you know, and make sure that it's hard, or changing to temperature. And I may be completely wrong on how you make hammers, but that's not my point. You get it, right?
Yeah.
So there's a lot of command line tools, and, you know, within the terminal or within the command line in Windows that you can use in order to compile your application, in order to be able to, you know, output your, you know, take your program and convert it to binary is what I'm getting at. So those command line tools are the ones that were probably used in order to be able to build Visual Studio with the programming language that it helps you debug and create and stuff like that. It's the tool that you use to make other applications. So Visual Studio is no exception. It has to go through the same process of somebody has to write the code in order to be able to display the information, and somebody has to write the code in order to help you build and run your application, by right clicking on it, by clicking some start button or whatever. Somebody had to write all that code. Otherwise, you would sit there on the command line and type the 20 commands that it takes in order to get that to run with a simple right click. Does that make sense?
Yeah.
All right. So let's get into .NET and C#. And I think I want to start with Visual Studio. So Visual Studio is what they call an IDE, an integrated development environment. So that environment is what you're going to use in order to develop your application. So the tool is integrated within the environment. It includes your debugger to be able to fix problems that you create as you write your code, and you're going to create problems, don't worry. It's what compiles your application. It's what runs it. It's what tells you that, something is working or something not working, or that you're, the code just isn't right. It's the tool that helps you with that. It can help you by telling you ahead of time that, hey, you're converting $1.05 to $1 and you're going to lose 5 cents. And it doesn't really matter what that monetary value is the fact is that you're going to lose data during that conversion. And the tool, Visual Studio, is what actually tells you that that's happening before you even compile your application. The last thing you want to do is compile your application, run it, and then when you're running it, you realize like, oh, I just lost 5 cents. That data loss could be a problem, especially if you're working with accountants, if you're working on some kind of accounting package. Who made it? Microsoft. Microsoft is the author of Visual Studio, and Visual Studio has existed since back in the mid 90s, maybe early 90s.
Wow.
And so, it's always been Visual Studio. And when .NET and C# came out, they called it Visual Studio.NET. And I think now they're just back to Visual Studio. I think they call it Visual Studio 2019, which is the latest version that's currently out there. They took out the .NET, they took out the core, they took out all this stuff, and they just said, it's just Visual Studio 2019. That's the version. Let's talk a little bit about C#. So C# is a programming language. You can compare it to other languages such as Java, not JavaScript, because JavaScript is something different, but you can compare it to Java. You can compare it to, I guess, Golang would be another one that you can compare it to. I would say you can compare it to Python, but Python, although C# can do a lot of the things that Python can't, Python is a specialized language for, a lot of like data studies, big data developers, people that are working with statistics, working with what kind of other, anything to do with like trying to figure out numbers. So yeah, we talked about who made it, C#, what is it? So yeah, you can compare it to languages like Java. And again, you can compare it to any other language, and it could probably do exactly what any other language can do. But it's more generalized, and there's like specific things that C# just really shines. And some of that stuff is obviously some of the Windows programming. So whenever you're working with Windows application, Windows services, and stuff like that, it really shines with that. They've really done a good job at working with websites and web APIs. They've also done a really good job at working with gaming. So there's a whole gaming framework that you can work with. Can it do statistical stuff? Can it do big data manipulation? Absolutely. But you're gonna have to program all that, where other languages have all those features built into it. And I'm talking more like Python. But it really is a very generalized language. Now, they've gotten it to work on other operating systems. So whatever you can do on Windows, you can do it also with Mac and with Linux, as well as Android as well, and iPhone. So, if you want to create some kind of game, you can use their gaming framework to run on Android, to run on iPhone or Xbox. And from what I understand, you can also use it for PlayStation. So you could create a game on PlayStation itself. Or you can create some kind of application that runs on iOS or Android. Let's say, for example, you want to create a shopping cart or some kind of chat application or a messaging application. You can create it to run on Mac. You can create it to run on Windows. You can create it to run on any of the devices, tablets, phones, and stuff like that. So it's very generalized. Where Python can run APIs, can also run Windows application, but it's not as performing. C# performs much better than Python. But when it comes to manipulating big data and doing statistical analysis and stuff like that, Python will outperform C#. And it's not so much that Python is faster than C#. It's just the fact that the libraries that Python uses are all written in much lower level languages that can access memory directly and really just outperform the calculations that you would use for any other language. Mm-hmm. All the other languages would have to go through their layers of their runtime and the operating system. And so that splitting of hairs when you're running large math problems and stuff like that, they run much faster if you're just running directly to the hardware. And so that's what Python specializes. It has all these libraries that go directly to the hardware and just can outperform using those libraries. So now from C#, let's go to .NET. So what is .NET? So we talked about the runtime that your programming language needs, right? That is basically what .NET is. .NET is a runtime. .NET, well, let's back up for a second. It's like, that's just kind of what is it, right? It is what C# runs on, okay? It came from the need of Microsoft needing a language that can be cross-platform. Now, originally, and this is very public information, they had taken Java and they changed it so that it ran how they needed it to run on Windows. And I don't know all the technicalities behind it, but they changed it so that it would run better on Windows than just any operating system. And Sun Microsystem, who owned Java at the time, said, no, stop. Just hold on for a second. Like, you just can't change it to run on Windows.
It sounds pretty fishy. Someone's trying to get an advantage over here.
Java is meant to run everywhere, and you just can't change it to run on Windows. It's like, no. You can't do that. So they went through this bloody court battle, and both companies bled so much money. I don't even know the dollar figure. It's up in the millions. They bled so much money going through these court battles. Eventually, Java won, and Microsoft lost, but Sun Microsystems, who owned Java, just had bled too much money, and they had to file for bankruptcy shortly after. And so at that point, another company bought Java, or I think they took in Sun Microsystem, a company by the name of Oracle, and they have this really nice database that a lot of enterprise level companies will use. but that's really where it came from. It was the fact that Microsoft lost this lawsuit, and they said, well, we need something like that. It's like, and so they hired this guy by the name of Anders Helsberg, who is, by the way, my hero. I got pictures with him at one of the Microsoft conferences. It was like, there's a story behind that one that's really funny. But he had been tinkering with code since, I want to say, college, maybe even before, I don't know. He attended the University of Denmark, and he was taking an engineering course. He was going to get an engineering degree, and he ended up dropping out, never got a degree. And so, and to this day, he doesn't have a degree in any computer science field or anything. But he worked on a particular, what was it called? It was called Pascal. He worked on Pascal, and he came up with this thing called Turbo Pascal, which would compile a lot faster. And then from Pascal, he went and wrote Delphi. He was with this company called Borland. And right around the time that they were having this battle, they were doing all these changes to Java, they hired Anders to help with this. But they realized that they were in a losing battle and they needed to come up with something else. And that's where C# was born. And with C#, they had to do the runtime. And Anders designed this whole runtime and programming language in such a way that you can actually have several programming language that run on .NET. So you can actually take another language like, say, Visual Basic that can do exactly what C# can do, and it would run on the .NET runtime. Eventually, Python was also created in such a way that you can compile it to run on .NET runtime. There's a website, and I forget the name of it. You could probably look it up and search how many languages run on .NET. And I want to say there's a couple hundred at least 100, if not more. But yeah, it's essentially, he designed this runtime so that any language can go through a compilation process and run in the framework. And we're going to get into how he actually did that. So it was created to satisfy what Java did, but Microsoft needed something that they could run on their operating system. And I think I already talked about what you can do with it. You can do applications that run on the operating system directly, whether it be Mac, Linux, Windows, Android, iPhone, tablets, whatever. But what's more important is like all the different types of applications that you can do with it. It's just like there's so many different problems that you can solve. And really, any business trying to make money and trying to make money through software has a problem, because they need that software written in order to make the money. And so that's where developers come in and be able to earn a very decent living with businesses that have these ideas. So .NET and C# are very, very, I want to say, closely related, but loosely coupled, because you can take C# and replace it with any other programming language that can compile to run on the .NET framework, and you could do anything that C# does. But what's neat about C# is that C# came with zero baggage. It didn't come with, like, say, for example, if you were to take an old language like C or C++, you have to keep all the backwards compatibility, because as soon as you release the next version that runs on .NET, it's going to break everyone else's application. And they would never upgrade to that latest version. So that's a lot of baggage to come with, where C# had no history. And they say, let's just take the best feature of every single language out there and put it into C#. And C#, was created zero baggage right from the start. And it's a very cool, very elegant language. I like it, and I've used other languages, and there's nothing that really compares to C# and its elegancy, the things that you can do, and whatnot. So it's kind of cool. So in a nutshell, .NET is a runtime, it's a framework, it's a compiler, it's a sandbox that protects you from having to program to a specific operating system. So you don't have to understand how Mac saves files or Windows save files or how to access a file on Android. Like all that's encapsulated and abstracted through this runtime. So you just have to tell the runtime, it's like, hey, go open this file. The runtime says, what operating system am I on? Oh, I'm on Windows. Okay, here's the command Windows. Go and open this file for me and give me the contents, What else is .NET? .NET is a gigantic library of code. I mean, there's a lot of code out there in .NET that does things that abstracts you from the operating system. It also has a type system. So every programming language has what they call a numeric type or several numeric types. You can do integers, you can do floating points, you can do decimals, you can do large numbers, small numbers, all these different types of numeric types. You can also do different types of characters. So you can have like one character, or you can have a string of characters, or you can have a collection of characters, and you can sort them and do all these things. So all these are just basic types that come with the runtime. You don't have to worry about, oh, I need to be able to accept some input from a user. It's like those inputs are interpreted as a specific type within the .NET runtime. And so all you need to do is just use them. It's like the user inputs it and you grab it from the runtime and you do whatever you need to do, whether you're going to save it, whether you're going to output it differently, or whatever it is, that type already exists. And it allows you to create new types that you specifically need for your program. So as long as you stay within that sandbox, it handles all your resources and it cleans them up for you. In languages like C and C++, in order for you to store a numeric value in memory, you have to tell the operating system, hey, by the way, I need memory space to store this number. And here's how much space I need. And then you can store it. And then once you're done with it, you tell the operating system, oh, by the way, I'm done with that memory space. You can take it back. I no longer need it. With C#, you don't have to worry about any of that. You just say, hey, I need an integer. Here's the value that I'm going to assign to a variable. I'm going to use it. And whether you discard it or not, it doesn't care. It'll do the cleanup for you. Now, once you go outside of the sandbox, and let's say you want to access a port of some sort to communicate through the internet, to communicate to a database, to communicate to the file system, that's going outside the sandbox. And in those cases, you do need to tell the operating system, it's like, hey, I need to open up a file handle, and here's the file that I'm going to access. And once you're done with it, you say, oh, by the way, I'm done with this handle. You can go ahead and just toss it and clean up whatever resources. But the code that you write, it almost like you wouldn't even know that. You know what I mean?
Mm-hmm.
Is that Cora barking in the background?
Yeah.
Cora, we're recording, Cora. So yeah, so that's how elegant the language is that you write it in such a way that you don't even realize that you're telling the operating system, these are the resources that need to be cleaned up. It's like the way you write it, it automatically just happens for you. And as we get into it, into those details, you'll see what I'm talking about. What else is a .NET? Okay, so let's go back. Let's go back in time and talk about how it goes from program to something that your computer understands, because it's a very, very seamless operation.
Mhm.
But there's so much that happens. Okay, so what happens is that you write your C# code, and when you compile it, it compiles to what they call an intermediate language. And that intermediate language doesn't get compiled until you actually execute your program. When you execute your program, what happens is that it runs through a second compiler. And that second compiler takes that intermediate language that took your C# and it took it into another language. It compiles it, and it compiles it down to the architecture of your processor. So if you're running an AMD Ryzen processor, there are certain things that you need to know about that processor in order for your code to run efficiently. The .NET runtime handles that for you. You could be running an iCore 3 by Pentium, or an iCore 5, or an iCore 7, or a 9. Each one of those is different from each other because they all have different performance barriers that have been broken through based on how the architecture is. Your C# code never changes because it gets compiled into an intermediate language, and that intermediate language, when you execute your program, it gets recompiled directly to the processor that you're running, and it runs at its most optimal performance. Now, one thing you might know is that when you open up your task manager and you see like the different cores
Mhm.
and processes, you may have one processor, but that one processor may have 4 cores, and those 4 cores may be running hyperthread, which shows that's four processors, right? In your C# code, you don't have to worry about utilizing all 8 of them because the runtime will take care of that for you. And there's certain things that you can do within the runtime that allow you to take advantage of being able to use all the cores at once without you having to actually program for it. And the reason is because when you're programming, you don't know if your user is going to have one processor with 1 core or 2 cores or 8 cores all running hyperthread, which comes out to 16. It looks like 16 processors. You don't even have to worry about all that. It's all built into the language so that you just run it and it's going to handle. It says, okay, I could run this task, and this task at the same time, and I'm going to just deploy them to the different cores in order to be able to run your code as fast as possible. So I know it's kind of
Yeah.
so
How the hardware, like, it plays a big part of the um, the whole thing too for .NET.
very much so. I mean, hardware is performance.
Mhm.
More memory, the more cores, the faster the hard drive you have, the faster your program's just going to run, right? So let's talk about when it compiles from your C# to the intermediate language. It outputs 2 types of files. One of them is an exe, and I'm sure you know what that does, right? It's an executable. And that's a file that you can double click on and it's just going to run. The second type of file is a DLL. DLL stands for Dynamic Link Library. Basically, an exe or another DLL can load that DLL into memory and utilize the types that are in there. And it can run the code and run the logic that is in those DLLs. You cannot execute those DLLs. You can only execute the exe files. That's just how they made it. How they made it and separated those 2 types. One's just a library, the other one's the actual executable that runs. Those 2 types of files are pretty much the only types of files that end up getting compiled to a machine language. There's other files that come with it, and as we start, working with C# a little bit more, we'll get into what those other types of files are doing. But yeah, I mean, it's all managed code. It cleans up after itself. You don't have to worry about, giving the memory back to the operating system. It just handles all that for you. And again, it lets you focus on the business problem without having to focus on the boilerplate behavior, looking out for a mouse click, looking out for keystrokes. All that is just boilerplate. It's this, stuff that you're going to have to code for if it wasn't built into the operating system. And so it kind of helps you out that way. Thoughts?
Yeah, it's a lot to process for sure. Getting into how computers work down to the hardware and processors and all that.
Yep. Yeah. It definitely, I think getting into a language like C#, it definitely exposes you to like, oh, wow, there's so much going on in the hardware that you don't really pay attention to. And even in today's form of C#, I mean, you're looking at version 8, version 9, I forget what version they're in. It hides a lot of those complexities. Back when you were programming in version 1 of C#, if you wanted to run multiple threads, you had to program for that. Now it's just kind of built into the language. The language just kind of does it for you automatically. But, there's still ways that you can go and do it manually if you need to, but there's no need for it. It kind of just does it for you, which is pretty cool because you never know how many processors a motherboard has that a user's going to be running. And so it really, if you can't take advantage of those processors, or if you have to keep track of it, you're going to have to write so much more code in order to like, well, how many cores do I have? How many processes can I run? It's like, oh, let the runtime just handle all that for you. You just go and sit there and launch it, and it'll queue up your stuff. Whatever it can run in parallel, it'll run in parallel. Whatever it can't, it'll just queue it up and run it in parallel when a task becomes available. And so think of it as making coffee. You can get the water or you can fill the basket, but you don't have to do one or the other first. You can do them at the same time, right? So you can take two people and say, hey, you get the water, I'll fill the basket. Well, you're instructing another person to help you, where the runtime just does that for you. The runtime just imagine you're going to make coffee and boom, there's two Jonathans. It's like one Jonathan goes and gets the water, the other Jonathan fills up the basket with coffee grinds. And once the water's been filled and once the basket's been filled, then pouring the water into the thing can then start. Well, the first Jonathan pours the water, the second Jonathan goes ahead and turns on the coffee maker so that it can start heating up the water and starts pouring it through the basket so that it catches. There are certain things that happen in sequence, but there's other things that can run in parallel. And so the runtime can handle that for you, providing that you program in a certain way. And we'll talk about that as we start, working on some of these samples that we're going to be going through.
Cool.
All right.
Fun. Yeah.
All right. So we are going to be reading a book.
Give it to me.
The book that we're going to be reading is by a gentleman of Mark J. Price, and it's a 4th edition, and it covers C#8 and .NET Core 3, although, yeah, those are the latest versions, C#8 and .NET Core 3. Let's start with chapter 1, and then we'll go, we'll see how it feels, because I know that you're running your other curriculum with React that you're going through. And so we'll start with chapter 1, and then we'll get together next week to be able to talk about what it is that they're talking about. Again, this is a fairly advanced book. I would tell you, let's go look at the Microsoft documentation. But Microsoft's documentation is so dense, I hate it. Like I could never find anything useful. There's nothing that I can say, let me start here and let me go to here and I'll be able to understand this section of the .NET framework or C#. It doesn't work that way with their documentation. It's very dense. They jump around, they reference a lot of things. And I think what we need is something that kind of takes you, level by level. And so we'll go ahead and get this book. Again, the name of the book, for those that want to follow along with this podcast, is called C# 8 and .NET Core 3.0, Modern Cross-Platform Development. I saw the book, and this is really the only book that is currently covering C# 8 and .NET Core 3.0, which are the latest versions in any writing. Yeah, so right now they're actually at version 5, which was released on November of 2020, right in the middle of the pandemic. So even though this is the latest book that we have, it covers up to version 3.0. It does cover the whole cross-platform capability, which is what's important. We'll get into the version 5 features as we're running through the book. And so I happen to know the .NET 5 features that are new, and I'll go ahead and cover it as we're reading the book itself. C# is actually, I believe it's C# 8 or 9, I forget. But yeah, I'll also cover the new features in C# as we run across those. So that is a book that we're going to be getting. We're going to get the Kindle format. I see it at Amazon for $20. So I'll go ahead and get you a code so you can purchase it. And anybody else that wants to follow along, that's what we're going to be doing. So,
All right. This is exciting. Like I get to learn C# while we're doing this podcast. It's kind of fun.
Yeah, no, it really is. I mean, and the fact that you've got other things that are going on, and this will be a pace that will allow you to absorb the content, and in such a way, you're never going to learn everything about C#. What's important is that you learn its capabilities so that you have the basics to go look it up. I do that all the time. It's like, how do I do this again? It's like, I know that I'd be able to change the type or do this or look up that. And I know the capabilities. I may not know how to do it. And I can just look it up and I was like, oh yeah, that's right. And it refreshes my mind enough to know that I can do it. And so that's really, this language and this, runtime is so big. You're never going to learn everything, but you want to learn enough to know all the capabilities of how to get something done so that you can go look it up and then you can go ahead and implement it the exact way that you see it, or you may have to change it, and I do that all the time. I change the way it's being implemented to fit my needs. A lot of times I just need the basics, like, how do you do this again? I'm like, oh, that's right. Yeah, that's okay. Yeah, but this is not exactly what I need, but I know what changes I need to make in order to make it do what I need. And so a lot of times it's just a starting point to go look up the stuff. But yeah, it's I'm excited for you. I'm excited, period. I think I haven't read a technical book in years. I mean, I've been solving so many problems that I just haven't had the opportunity to actually read a book and it's like, oh yeah, I see what they're talking about. Like, ooh, look at that. I didn't know that. It's like, so I know I'm going to learn something out of this too. So I'm also looking forward to it. All right. I would say this is wraps up episode 1.
Yep.
And yeah, we'll get together next week. Same bat time, same bat channel.
Hopefully we'll have a name by next time too for the podcast.
Yeah. We need a name. We need a name in order to publish it. Otherwise, we won't be able to publish it. How will people find us? No, this is cool because I mean, if this podcast helps other people learn C#, I think that'd be kind of cool. You know,
Yeah.
it's something. Programming is something that you don't need to go spend several thousands of dollars, tens of thousands of dollars to get a degree. You need a degree. Go get a degree, whatever you want. You know, it's like to be respected in any industry. Like you need to show that you've gone through the ropes of a university system, and I think it's more important that you just get a degree just to show that, like, hey, I can complete something, and I can do. You know, I'm capable of learning. That's really what a degree shows you, shows to other people. But programming is really more about enjoying solving problems for, you know, through software, you know, and if you enjoy it, you're going to have a blast, you know. It's a decent way to make a living. I wouldn't say that's the one thing you need to focus on, because it is a lot of work, you know. I mean, you're working your regular day job and you're going home or waking up early and doing studying, which I do the same, you know. I do exactly the same. You know, I'm working my day job and I come home and well, right now we're in a pandemic, so we're home anyways, but as soon as I shut down my work computer, I open up my personal computer and I start doing research. Right now I'm also working on some educational videos for a company, and once I get that done, I think, you know, I might be able to use this podcast to announce it. So once I get that done, it's due in April, end of April, so April 30th. And so once I get that done, I'll go ahead and announce it, where it's posted and how you can get to it. And you know, it'll be a nice little plugin for hopefully we have maybe 2 listeners by now. All right, so I'll go ahead and stop the recording.